All right, we're going to start the statistics unit. This is my very favorite unit in this course. It often lends itself to us having the most kind of hands-on activities, and it's very real world. We get to look at real world data, and we get to use data to help us make decisions. And that's the really cool thing about statistics, is all it does is just give you facts, and then you can use those facts to help you make a whole bunch of real world decisions. And you use statistics all the time. Every single day you use statistics. You use statistics when you try to decide what clothes you're going to wear in the morning, right? When you dress for the weather. You use statistics when you think about, are you going to speed down the highway on the way to school in the morning? Because how likely are you going to be to get a ticket for doing that, or how likely are you to get into an accident? So you're using data all the time to make decisions, and statistics is just really awesome because what it does is it gives you that data and allows you to make the decisions. So the thing that's really kind of cool about this unit is that there's some math that is going to be correct or incorrect. There's some calculations you're going to have to perform that are either going to be, number. But after that, you're free to kind of use those numbers however you like in making decisions. So for lots of these questions, the extension for them doesn't actually have a real true answer. It's up to you in how you use this information. And I really like that part of this unit. It makes some students feel uneasy because they're not sure how to answer it. They're scared they're going to get something wrong. But I just think that it kind of really shows you the power of math, in that it's definitely not as black and white as a lot of people think it is, right? It's open to some interpretation, and statistics give you a little bit of wiggle room that lots of other things don't in math. There's going to be some answers that are kind of close to what they should be, but not really, and you're going to have to use some good judgment to determine whether or not something is true or not. So we'll get into that as time goes by, and right now we're just doing a really basic kind of introduction to statistics. And one of the big ideas in stats is that we can't always gather data on every single possible person or every single element in a population. So if I want to know what happens, what the typical Canadian is doing in quarantine, I really don't have the resources or able to poll all 35 million Canadians to find out what they're doing in quarantine. So instead of actually studying whole populations, we might just take a sample of that population. And there's a lot of math, and there's a lot of kind of ideas and background knowledge when it comes to sampling. And there's a couple of that's mentioned in your notes, but this is a really big kind of, there's lots of calculations and things that you can do to make sure that your sample is representative. We don't need to get into any of that, but if you take some university stats courses, and I'm sure lots of you will, stats shows up in so many fields. If you want to be a psychologist, you'll use stats. If you want to be an economist, you'll use stats. If you want to, I took it to study science and study the ecology. Courses that I was taking really required stats for me to be able to continue. So it's kind of all over the place. Stats shows up everywhere, business and in science and in in a whole bunch of humanities as well. So you'll see if you take those courses, there's a whole bunch more going on behind the scenes when it comes to samples versus populations. We're not going to worry about that, right? Our population is just the entire set of possible people. So a population could be all of the students in our class. Okay, a population doesn't have to be the population of a country or the world. You can define it however you like. Okay, and then from there, if it's not possible for you to gather data on every single element in that population, then you would do some really good math to be able to determine what makes a good sample, and that would be hopefully representative. And so your sample would be representative. Okay, represents, and we want it to be free from bias. Okay, and your notes kind of goes along with that. If you want to gather information on shopping habits of teenagers, and you go to the mall on Saturday, and you know, when there wasn't a pandemic going on, and you asked all of the teenagers at the mall that you saw, or you asked the first 50 of them, a sample. It's a really biased sample because you've, you know, you're not gathering a wide variety of teenagers. You're gathering the people who clearly like to shop because they're at the mall. So I know that you've done some thinking about bias in, you know, in grade 9 stats units. So we're not going to spend too much time on that, but we want to make sure that we avoid bias also. Okay, what we are going to do is we're going to do a bunch of calculations, and we're going to look at measures of central tendency first. And you might recognize these. I know that I covered them in some of my middle school classes when I was back in the day when I was a middle school teacher. So you might have heard of mean, median, and mode already. If you haven't, they're pretty straightforward. These are measures of central tendency because they tell us about what's happening in the middle of our data. Okay, and you know, that kind of gives you that sense of what's that average element like, that one right in the middle. And there's actually a couple ways to determine that. And the first one is the mean, and this one is actually our average. Right, we use the word average and mean kind of interchangeably. So our average, what we do is we add up all our values and we divide by the number of values that we have. Okay, so the mean can be heavily influenced by very high and very low values. Okay, so you know, you might have seen that too if you're, you know, doing really well in math class and you're and it seems to pull your average down. Right? So that outlier can very strongly influence a mean as well. So when we don't want to look at our mean score, we might look at our median score. And this is actually the median. It's the middle, right? Median means middle. Think about a road. The median lane is the middle lane, right? So median just means middle, and it's the piece of data that's exactly in the middle of your data when it's in order. Okay, so we have to put it in order first, and then we just look at which one's in the middle. So if I had, you know, some data here, you know, I had 1, 2, 4, 8, and 9. Well, they're in order, and 4 is the number that's in the middle. So that's my median value in this group. Okay, and last but not least is our mode. And I always remember this because mode is spelled M-O-D-E. So M-O, if you think about most often, M-O, right? Mode is the value that shows up the most often in our data. And it can be a really helpful measure of central tendency. It doesn't really speak to the middle too much, but it does tell us mostly kind of what's going on. And I think a really good time to use the mode for measurement would be, you know, if you were stocking shelves in a clothing store and you needed to know, you needed to order some jeans. Everyone was gonna, you worked in the Gap, and everyone was buying jeans, and you were stocking the shelves with jeans, and one size, maybe size 7, was the most common size that people purchased. So that would be the one that you'd want to know that. You would want to know what size do most people purchase, so that you have lots of that when it comes to stocking your shelves in your store. So it seems like it's kind of a silly little measurement, but it actually shows up and can be very helpful to us. We don't often think about it as a measure of central tendency, right? We don't think those things, because they always seem so simple, we don't think of them as being statistics, but they're really important and really helpful to us. There is kind of one thing that I want to point out when it comes to the mean, because we're going to see this often throughout this course. You're going to see mean is going to be used, or I'm going to use two symbols kind of interchangeably. So the first one I'm going to use is X bar. And that's what it's called. It's called X bar. And that's the mean when you are using a sample of data, not an entire population. So we are not going to worry about that. Like we're just doing kind of scratch the surface statistics in this course. So we're going to use X bar and the other symbol, mu. Okay, it's a Greek letter. Yay, we keep adding Greek letters to our list. You guys are going to be fluent by the time we're done in math. Okay, and it looks like that. And mu is the symbol for population. And again, we're not going to stress that in this course, but if you move on to post-secondary statistics courses, you will definitely have to worry about the difference between X bar and mu. Okay, median doesn't have its own special symbol, and mode doesn't either. Okay, lots of our calculations are going to use this mean. So again, we're going to use X bar and mu interchangeably. So don't worry about that. If you see either one of those symbols, you can just think of it as, oh, right, that's the average, and I can calculate the average. All right, so let's do an example. Here's an example, first example in your notes. Here's a set of data. It's a pretty kind of boring set of data. It doesn't actually give us any context. It's just a bunch of numbers. We don't know what they represent, and we just want to figure out what the measures of central tendency are. Right? That's what the question's saying. Is you know, figure out, how do we figure out the mean? Well, to figure out the mean, we have to add up all of the values. And you know what? Let's use X bar. Let's use X bar for this and make ourselves look really fancy for using these fancy new symbols. All right, so X bar means we take all of the numbers that we have and we add them all up. And you've done this plenty of times when you found your average, probably on your report card, or you know, a mark in class, or maybe in some sports stats. And then we add them all up. Oh, it's a little blurry. There we go. And we divide by the number of data points we have. So we just want to be really careful, because it's easy to make mistakes with this, and we want to count up all pieces of data carefully. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 14 pieces of data. So we're going to add 12, 8, 3, 15, 7, 4, etc., etc., etc. And when we do that, and we divide by 14, and I encourage you to please put this. Okay, so follow along, put this in your calculator. You should get 10.64. Okay, so that's it. That's our average. That's our average value. And it's a reasonable number, right? Our lowest value is 3. Our highest value is an 18. And 10 is in between those numbers. That's a reasonable number. Okay? So that's our mean, right? X bar. Our median, now remember we're looking for our middle value, and students often forget to do a in order. You have to put these in order, so don't forget that step. Okay, And this can be really kind of a pain in the butt. So I encourage you, as you're kind of figuring this out, check them off. So the first number is, the smallest number is 3. And our next smallest number is 4. And then we have 7, and we have 2 7s actually. So we want to make sure we have 2 7s on our list. We have 3 8s. Right, 8 shows up 3 times. And our next number, we have no 9s, okay, but we have a 10. We have no 11s, but we have a 12. And we have a 15, 15, and a 15. So we have 3 15s. And we have an 18 and a 19 left. So I just kind of kept track of the numbers that I used. I didn't cross them out. Sometimes students cross them out and then they can't read the numbers when they're trying to do something different. So yeah, just kind of keep track. And then just go back and count and make sure you have all the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. I have all 14 pieces of data there. So I need the middle numbers. Now, when we have an odd amount of digits, it's really easy to find the middle number. But when we have an even number of digits, right, we have these two guys are actually in the middle, right, because we have 3 6 pieces of data on this side, 3 6 pieces of data on that side. So these two guys are in the middle. We need to find the average of these two, right? So 8 plus 10 over 2 is 18 over 2, which is 9. So our median value is 9. Okay, so you only have to do that. You only have to find the average when you have an even number of data points. If you had an odd number of data points, then it would just be the number in the middle. Okay, remember when they're in order. And then last but not least is our mode. Our mode is what shows up the most often. And if we put these in order, it's actually easier to see the mode from our list in order than it is from our original list. So I have 3 8s here, and I have 3 15s. So both 8 and 15 show up more times. Like there's only 2 7s, right? So 8 and 15 show up more often than the 7s or any other number. So we have 2 modes this time. We have 8 and 15. Okay, you can have definitely have more than one mode. It doesn't have to just be 2. It could be 3 or 4. But at some point, you're going to get to a place where you can also have no mode. So if every single piece of data was different, we wouldn't say that the mode was each and every single number, right? We would say there was no mode. Okay, but there will always be a median and there will always be a mean when we have quantitative data, when we have data that's in number form. Okay, so one kind of last point that this problem doesn't really speak to, but the next problem in your notes, so that's all written out for you that and I'll let you read through it, is these measures have the same units as the data. Okay, so units are obviously very important to us in math. If this was, let's say this was, I don't know, measured in grams, right? We were measuring the weight of something and we had all these different measurements. And then our X bar would be 10.64 grams, and our median would be 9 grams, and our mode would be 8 grams and 15 grams. Okay, the data in this question didn't have any units, so we don't have any units in our answer here. But you'll see in the next question in the notes that there's definitely some units in the question, and you'll need to make sure you have the units in your answer. Okay, and then what we would do is we would use these measures to tell us, to help us make some decisions. There are 2 other important words that come up when usually associated with mean, median, and mode. First is our range, and the range is a difference between the highest and lowest value in the set. Okay, so in our set of data. So if we look back at the last data, when we look at our median, when we put everything in order, our lowest value, or sorry, our highest value was 19, and our lowest value was 3. So we had a range of 16. Personally, I think that this part of the range is much more informative than this part of the range. Okay, so I think that you can get a lot more information from 19 minus 3, or seeing that this is the highest and this is the lowest, instead of just looking at what the difference between those numbers is. But we can see that that's a pretty big range of numbers, 3 to 19, if we were, right? So sometimes we just want to know the difference between those. And that can kind of speak to outliers. And there's obviously some mathematical ways to describe what makes an object or makes a data point an outlier. We don't need to worry about that math in this course, but we do definitely want to kind of see things as being seeing data points as being very different from something else. So from the rest of the data. So if we look at somebody's report card marks, and let's say somebody's report card looked like they had a 92 in one class, an 89 in another class, maybe a 93 in a third class. Fourth class they had, well, I don't know, maybe 91%, and then in a fifth class they had 56%. It's pretty clear that this class stands out from the rest of these data points, right? These guys are very close together. This is very far away from any measure of central tendency. So it kind of is an outlier. And they're really, often that's where the really good stories are, actually. So, I want to know what's going on. And why this person has 56% in one class and a 90 average in all the rest of their classes. So outliers can be very informative. They can always they also mess around with our data a little bit, which is okay. That's good, and it definitely can lead us to more discovery in math classes. Okay, so that's the mean, median, mode. And range often goes along with those guys, so you often have to calculate all 4 of those. Just note that range is not a measure of central tendency. Okay, it doesn't tell us about the middle, right? Central tendency is talking about which ones tend to be in the middle, in the center. Range doesn't do that. It tells us about what's happening on the outskirts of the data, very, very low end and very, very high end, and how far apart is that high and that low value, right? And outliers kind of fit with that idea of range as well. So range is not a measure of central tendency. However, it often gets calculated and included in those questions. So you often find the mean, median, mode, and range of some data. Okay, I hope that makes sense. Please let me know if you have any questions. I encourage you to read the second problem because it goes on to get you to make a decision about how this mean, median, mode, and range can influence a choice that somebody is making. And I'd like you to read that over. Wonderful lesson, guys.